Today in this video we are going to solve a nice geometric problem. Two vertices of a square lie on a circle of radius r and other two vertices lie on a tangent to this circle. We have to determine the length of each side of this square. We have to determine the length of each side of this square. Here vertices of a square lie on a circle of radius r and other two vertices lie on a tangent to this circle. We have to find out the length of each side of this square. We have already drawn the figure here. This is the square and this is the circle. Two vertices A and D lie on this circle and other two vertices B and C lie on the tangent to this circle. Now, we have to determine the length of each side of the square in terms of r. Here you can notice that a right angle triangle is formed, which is EAD. This is right angle triangle because angle EAD is right angle, that is 90 degree, because all angles of this square are 90 degree. So, this is right angle triangle, and you can also notice that two trapezium are formed in this figure. These trapeziums are OEBG and other is ODCG. Here radius of the circle is given as r, that is EOG are radius of the circle. This length is r, this length is r. Now we can say that the sum of the areas of right angle triangle and the two trapeziums is equal to the area of the entire square, because this square is formed by this right angle triangle and these two trapezium. So, sum of the areas of this right angle triangle and these two trapeziums is equal to the area of the entire square. Now, area of right angle triangle, area of right angle triangle EAD is equal to half multiplied by its base multiplied by its altitude. Its base is AD and its altitude is AE. This is equal to half AD multiplied by AE. AE is equal to AB minus EB. And also AB is equal to AD, because AB and AD are both the sides of the square and all sides of the square are equal. So, AB is equal to AD equal to DC equal to BC. So, we can write AD in place of AD in place of AB. So, this is equal to half AD multiplied by AD minus EB, because all sides of this square are equal, length of all sides of this square are equal. So, AD equal to DC equal to BC equal to AB. So, we can write AD in place of AB. Now, suppose AD equal to x and EB equal to m. AD equal to x and EB equal to m. So, this area is equal to half x minus m, half x multiplied by x minus m, and sum of the areas of two trapezium. Trapeziums, EOGB and ODCG. EOGB and ODCG is equal to, we have already known the formula for the area of any trapezium. This area of any trapezium is equal to the half sum of the length of the parallel sides, sum of the length of the two parallel sides of this trapezium and perpendicular distance between these two parallel sides. So, we can write area of this trapezium is equal to half multiplied by parallel sides. Parallel sides are EB and OG. EB and OG multiplied by the perpendicular distance between these two parallel sides, which is BG, plus half of sum of the length of two parallel sides, which are OG and CD. Multiplied by the perpendicular distance between these two parallel sides, which is GC. These are two trapeziums because this EOGB is a trapezium because OG and EB are parallel, because OG is a radius of the circle passing through the point of contact. So, OG is perpendicular to the tangent BC, and also EB is perpendicular to tangent BC because this angle is 90 degree for this figure is a square, because the figure is a square. So, all angles are equal 90 degree, this is 90 degree and this is also 90 degree because OG is a radius of the circle passing through the point of contact. So, OG is perpendicular to this tangent BC. So, this is 90 degree, this is 90 degree and these are two perpendiculars perpendiculars to the same line BC. So, they are parallel. So, OG and EB are parallel. In the by the same logic, we can say that OG is also parallel to DC because OG is a radius passing through the point of contact. OG is perpendicular to the tangent BC and CD is also perpendicular to the tangent BC because this angle is 90 degree, because this is a angle of square which is 90 degree. So, these two angles are 90 degree. So, OG and CD are two perpendiculars on the same line BC. So, they are parallel to each other. So, OG is parallel to DC. So, this is a trapezium and this is a trapezium because these two sides are parallel and these two sides are parallel. So, they are trapeziums, and also these are the areas of these two trapeziums. Now, this is equal to half EB. EB is considered as M. So, M OG. OG is the radius of the circle. So, this is R. BG plus half OG. OG is R and CD is considered as X. GC. Now, BG equal to CG. BG equal to CG. We can write BG plus half R plus X. GC is equal to BG. BG equal to CG because if we extend this radius to the point this is if we extend the radius to the point F, that is we have a figure BGFA. Here this angle is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. So, obviously, this angle is 90 degree and this is a rectangle, So, FG equal to AB and BG equal to F, and by the same logic we can say that GCDF is also a rectangle, because this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. So, obviously, this is 90 degree. So, this is also a rectangle, and these two sides are equal and these two sides are equal. Here also OF is perpendicular to the chord of this circle. O is the center, a perpendicular drawn from the center of the circle to its chords. This perpendicular bisects the chord. That is OF bisects AD. So, we can say that BG equal to F and CG equal to FD. Because AFGB and FDCG are two rectangles. So, as these two are rectangles, so opposite sides of each rectangles are equal. That these are two opposite sides, that is BG equal to F, and these are two opposite sides of this rectangle. So, CG equal to FD, and also OF is perpendicular drawn from the center of the circle to its chord AD. So, OF bisects AD. Now, OF is perpendicular drawn from the center O to the chord AD. So OF bisects AD. We have already known this from a theorem of circle. So OF bisects AD. So OF, we have known this from the theorem on circles. So OF bisects AD, the chord AD. So AF, that is AF equal to FD. So we can say that BG equal to CG. So BG equal to CG. So BG equal to CG, because BG equal to F and CG equal to FD. AF is equal to FD. So BG equal to CG. So we can write BG in place of GC, because BG equal to CG. Now, this is equal to half M plus R BG equal to CG. Also these are equal to half of BG plus CG, that is half of BG plus CG is equal to BC. BC is the side length of square. Side length of square is considered as x. So BC equal to AD. So half of x, that is x over 2, x over 2. So, this is x over 2, b is equal to x over 2 plus half of r plus x over 2, b is equal to x over 2, b is equal to x over 2. This is the sum of the areas of the trapezium. So, we can write the sum of the areas of right angle triangle and two trapeziums is equal to the area of the entire square. So, we can say that we can write, so you can write half x minus m plus half m plus r x over 2 plus half r plus x over 2 is equal to half m square, half is equal to area of the entire square. Area of the entire square, side length of square is considered as x. So, area of the square is x square. This is equal to x square. This is equal to x square. So, we can write x, this is x over 2, this is x minus m half, this is half x minus m x plus m plus r x plus this is half x multiplied by so we can write the sum of the areas of the right angle triangle and the two trapeziums is equal to the area of the entire square. So, we can write half x, area of the right angle triangle is this, half x minus m plus sum of the areas of these two trapeziums which is this, that is half m plus r x over 2 plus half r plus x over 2 is equal to the area of the entire square. Area of the entire square is x square because side length is considered as x, that is x square. So, this is 2x, we can multiply both sides by 4. So, this is 2x multiplied by x minus m plus m plus r x plus r plus x is equal to 4 multiplied by x square. This is, so 2x square minus 2mx plus mx plus rx plus x square equal to 4x square. This is 2mx, that is mx, 4x square, 3x square, that is x square plus mx plus mx, this is minus 2mx minus 2mx plus mx, that is minus mx. So, this is x square plus mx minus 2rx minus 2rx equal to 0, x square plus mx minus 2rx equal to 0. Now, from the right angle triangle EAD, from right angle triangle AED, from right angle triangle AED we can say that square of the hypotenuse is equal to the sum of the square of other two sides. This is known from the Pythagoras theorem. So, we can write square of hypotenuse, that is ED square, is equal to sum of the square of the other two sides of this right angle triangle. Other two sides are AE and AD. Sum of the square of other two sides is AE square plus AD square, A square plus AD square. Now, ED is the diameter of this circle, because ED is a line passing through the center of this circle, and its two extremities lie on this circle. Extremities are E and D. Two extremities E and D lie on the circle, and this line ED is passing through the center of this circle, So, this line is called the diameter, is a diameter of this circle. So, length of this diameter is 2r because its radius is r. Radius of this circle is r. So, length of diameter is 2r. So, this is 2r. This is 2r square is equal to AE. AE is equal to AB minus EB square plus AD square. This is AB and AD all are equal. So, AB and AD is equal to x, because length of each side of the square is taken as x. So, AB is equal to x minus EB, x minus EB is taken as m. So, this is m square plus AD is also x square. This is length of each side of the square is taken as x, and EB is taken as m. Length of EB is taken as m. This is so 4r square equal to x square minus 2mx plus m square plus x square. So, we can write m square minus 2mx, m square minus 2mx plus 2x square minus 4r square is equal to 0. This is m square minus 2mx plus 2x square minus 4r square equal to 0. This is a quadratic equation in M. So, by Siddharacharya's rule, we can find out the roots of this quadratic equation, which are M is equal to 2x plus minus root over of 4x square minus 2x square minus 4r square over 2 multiplied by 1. This is equal to 2x plus minus 4x square minus 8x square plus 16r square over 2. This is equal to 2x plus minus we can take common factor of this discriminant as 4 and its square root is 2. So, we can write 2 multiplied by 16 r square 4 r square minus x square, this is over 2. This is equal to x plus minus root over of 4 r square minus x square, 4 r square minus x square. This is the value of m. These are the roots of m. X plus minus 4 r square minus x square, 4 r square minus x square. Now, we have already got this equation x square plus mx minus 2 rx equal to 0. Now, x square plus mx minus 2 rx is equal to 0. Here we can put the values of m. So, x square plus m is this x plus minus root over of 4 r square minus x square multiplied by x minus 2 rx is equal to 0, 2 rx equal to 0. We have put the value of m in this equation, we have got this result. This is x square plus x square plus minus x multiplied by 4 r square minus x square minus 2 rx is equal to 0. That is 2x square 2 rx minus 2x square is equal to plus minus x root over of 4 r square minus x square. We have got this equation 2 rx minus 2x square is equal to plus minus x square root of 4 r square minus x square. We can take square of both sides of this equation. We can take square of both sides of this equation. By squaring we get 2 rx minus 2x square whole square is equal to plus minus x root over of square. This is. So, we can expand this square. After expanding it we get 4 r square x square minus 8 r x cube minus 8 r x cube plus 4 x 4 is equal to x square multiplied by 4 r square minus x square. 4 r square x square minus 8 r x cube plus 4 x 4 is equal to 4 r square x square minus x 4. These are cancelled out. So, 8 r x cube is equal to minus 5 x 4 minus 5 x 4. So, 5 x 4 equal to 8 r x cube. So, 5 x equal to 8 r because x not equal to 0. 5 from this equation we get 5x equal to 8 r. So, x equal to 8 r over 5, 8 r 8r over 5. This is the length of each side of the square. This is the length of each side of the square, which is expressed in terms of r, and this length is 8r over 5. 8r over 5 is the length of each side of the square whose two vertices lie on the circle whose radius is r, and other two vertices lie on the tangent to the circle, and this length, that is the length of the square, length of each side of the square is 8r over 5.